Folks, we're going to get started now. Welcome to the final session of the 2023 to 2024 Forest and Climate Learning Exchange Series. I'm your host, Tony Mazza, the Interim Director of Policy at the Society of American Foresters. I'd like to first acknowledge and thank our co-host for this year's series, the Forest Carbon and Climate Program at Michigan State University. Today's presentation will feature Lilli Kaarakka, Assistant Professor at Cal Poly, who will present on managing forests for carbon offsets, opportunities, risks, and the way forward. We're sincerely thankful to Lilli for taking the time to speak with us today. Before we get started, I'd like to briefly share a few housekeeping details. To automatically receive registration details and information regarding upcoming webinars, please join our mailing list by scanning the QR code on your screen or by emailing forestc@msu.edu. A recording of this session, along with a copy of the slides and any supplemental resources, will be posted to the Learning Exchange Series webpage. Please note, this presentation will be followed by a Q&A session. You can use the chat or Q&A function at the bottom of the Zoom interface to submit your questions at any point during the presentation, and we'll do our best to address as many questions as we can today. Attendees are qualified to receive CFE credits from SAF. The credits will be automatically applied if you register for the event with the email associated with your SAF account. Similarly, attendees are qualified to receive CEU credits from ISA. Please email forestc@msu.edu with your CERT ID to receive those credits. With housekeeping over, I will now hand it to Lilli to begin the presentation. Thank you so much, Lilli.
Okay. Let me just share my screen. Good old Zoom era, still looking where to go. There we go. Okay, so I'm hoping to get an okay from people.
That looks good,
Tony,
Lilli.
it looks good. Okay, great. Thank you. So good afternoon. Here in California, we're just at lunchtime, but I think people joining from the East Coast and somewhere else in the US are almost ready for the afternoon. I appreciate Tony for the kind invitation as well as introduction. So my name is Dr. Lilli Kaarakka, and I teach silviculture and forest management at Cal Poly in Central California. Outside of my wonderful job as a teacher, the time that we have left outside of that, we try to figure out in my research group what's happening with forest carbon offsets kind of around in the U.S. markets. So I'm kind of thinking of why are we here today, and not to go into philosophy of existence, but more into what I will talk about today in this 45-minute long seminar. Is that I will start with going over some of the basics of forest carbon dynamics. I think we hear a lot of carbon jargon in the sort of public sphere, as well as in forestry and in the general public discourse. So I think kind of starting with the foundations of what sections of carbon that we have in forest systems are we interested in. I'll briefly also talk about land management and nature-based solutions as kind of a foundation for the research that we're doing, as well as offset markets in the US. And an important question, I guess, for a lot of the research that we do in forestry, not just in offsets, we kind of have to think about the way forward. And I have a couple slides about that with some recent developments coming all the way from Washington for carbon offsets. Quick carbon recap, where, how, and why. As we know, for the ones of us who have a background in forestry as well as ecology and biological sciences, we tend to think that there are obviously two carbon storages. We talk about slow carbon, so we're thinking of carbon that's deep in rock, soil, ocean, as well as the atmosphere, sort of out of the reach of the human hands. And essentially that carbon only returns to atmosphere through volcanoes. And since this is a slide that I sometimes use in classes too, students at least appreciate nuggets of information that are somehow relatable. So I want to highlight too that humans emit 100 to 300 times more carbon into the atmosphere than what volcanoes have historically done. An important point there. Fast carbon. So this is something that a carbon molecule essentially that cycles to different life forms, including woody biomass in our biosphere. And this change occurs within the decade or annual scale. And in some cases, obviously, even in the minutian, second scale when we think about the details of photosynthesis. And thinking of how forest management and silviculture relates to carbon, this is the sort of pool of carbon that we're interested in natural resource management and forestry that we can affect with our management. Where does all this carbon go? So we have emitted all this carbon dioxide post-industrial revolution into different things. And the bigger drivers are fossil fuel emissions. So thinking of combustion from different sources, as well as land conversion, particularly thinking of deforestation and converting forested land globally into use in agriculture. So what are the sinks? So where does all this carbon end up in? So almost half of it has been deposited in our atmosphere, as we've discussed in the past and as we know from the previous slides. But a lot of it is also deposited in the oceans, and about a third goes into our forested or land biomes that have dense vegetation on them as to absorb that carbon. So where does all that carbon end up if we think about specifically forest or forest industry per se? So approximately a quarter goes into the forest trees, essentially, so woody biomass, thinking that half of woody biomass is carbon. A lot of it is deposited in dead woody soil. We have dead trees, post-disturbance, for example, as well as wood products. But what's an important point to highlight too here is that more than 75% of the sequestered carbon in the United States is found in organic matter that's not inventoried. So this includes components in soil, for example. Many of you here in the call might work for the U.S. Forest Service or have research components with them. We don't think currently the federal government doesn't include forest soil carbon in the inventory data, nor do the private entities. Not to mention all the other organic carbon stocks that are outside of the sort of sector of forestry as well. So carbon sinks in forest. In the US, an approximately 211 teragrams of carbon are essentially stored in woody biomass, soil and dead woody biomass. And this equals, I think the number has gone up in the current report, but this is from 2022. But that is more or less 12% of the greenhouse gas emissions that the United States produces every year. And private vehicles are responsible for approximately 11% of that. So we can kind of think that forests essentially are sequestering enough carbon to allow us to drive our private vehicles around. I'm based out in California, so of course we've seen a lot of devastating disturbances in forest systems, and we'll talk about those a bit later. But still, even taking all these changes in our forest systems into account, harvesting is still the most extensive disturbance in forested systems in the US in terms of area as well as carbon. So why do I want to say this? This is not to highlight some sort of negative that the forest industry or forest management essentially implies on forests, but instead highlight how important management decisions are in forestry, essentially, not just thinking at the stand level, but also at the entire country level. Okay, so blank slide. We have, as mentioned, experienced these large-scale disturbances in forested systems, and we are seeing rapid changes in environmental conditions, as well as changes in how human interaction changes forested systems, not just harvesting, as previously mentioned, but causing potential disturbances at very large scales. So the image that you're currently looking at is a tower picture of Dixie Fire in California that occurred in 2021 that burned almost 1 million acres. And this picture is actually taken from a PG&E weather tower. And what essentially what was faulted for the fire was PG&E's faulty equipment. So, okay, so we've established that we have this disturbances, we have fire, we have compound disturbances in the environment, but we still have a lot of this carbon. So what next? So we usually have this discourse in forestry that, conversion from forest to a different system or deforestation essentially is happening, in faraway lands, and it doesn't involve us here, sort of in the Northern Hemisphere, particularly in the US. But this is from a great article published in 2021 in Nature, where they found actually that there's been a very rapid change in a lot of the forested systems and in the US becoming sources of carbon instead of being sinks. That's probably a bit hard to see since you guys are on Zoom, but luckily I've shared these slides with Tony so you can kind of zoom into them once you see them on the website. But if we kind of focus on the section of North America and particularly northwest area, thinking Oregon, California, Washington, and parts of Canada, we can see that there's a large source event happening, essentially meaning that carbon is being released from those systems. And what is likely driving it is obviously large-scale fires, as well as other disturbances. So thinking of beetle outbreaks, as well as ongoing drought events. So this is, again, another map of just thinking of the US. So net carbon change. This is from 2006 to 2010. And during that time frame, the carbon loss was essentially driven by harvest and to up to 70%, as well as fire to 15% and insect damage. But that said, even during that time frame from 2006 to 2010, there are multiple disturbances that were driving the loss of carbon from these systems. And after 2010, we've entered an interesting era. The Forest Service has recently estimated that approximately 170 million trees have died in the Sierra mountain range in California because of drought and bark beetle and fire, all these kind of compound disturbances interacting. So we've seen long periods of drought here in California and parts of the West. And that has increased more or less the loss of carbon in those systems. And the picture that you're currently looking at is from the U.S. Forest Service, and you're looking at southern Sierra stand in California, completely ravaged by bark beetles. So there's this complicated relationship and kind of going a bit into the ecology between wildfire and bark beetle. And why do I bring this up is that when we talk about sequestering carbon and storing it long term in our forested systems in the US, we have to take into account first the ecology and the sort of natural disturbance dynamics of those stands, because those will, of course, heavily affect how long that carbon is going to be stored there. And also, how are we going to respond to these environmental changes that are driving these disturbances so fast that it puts not just the carbon, but also a lot of these carbon offset projects at risk. If we kind of take a step back again and think about what are some of the global trends in forest, and we are definitely seeing a lot of climate-induced mortality. These are from different publications in the last decade or so. And kind of summarized, I won't go over the specific pictures, but in summarizing, we can say that forests across the world are facing multiple stressors. So we're thinking drought, fire currents, hurricanes, tornadoes. We're currently seeing this high likelihood of hurricane events on the East Coast this year. And a lot of these changes, while being part of like an endemic part of the ecosystem per se, are also being exaggerated by climate change. So they're becoming more intense. So you might be wondering that, okay, so the title of the talk, again, was, thinking of carbon offsets and how those relate to woody biomass and carbon in our managed forest, is that, again, like I said, we have to take into account what sort of drives changes in these ecosystems. Okay, sorry, I saw a question and I'm prone to instantly looking at the question when it pops up. So why are we talking about carbon and changing conditions? Is that again, in forestry, we manage resources in a long-term horizon. Many on this webinar identify or recognize the fact that rotation times for different types of trees that we manage in the US vary between 25 to 120 years. So the time horizon is already fairly long. But what we're already witnessing in our current day changes to environmental conditions, not just at the stand level, but also thinking at landscapes and regional changes, is that change is occurring at a very fast rate. And a lot of the trees that we do manage are having a harder time responding to that change in that sort of time frame that expected. So that we don't always focus on this quote unquote negative. I always want to talk about forest management specifically as having the sort of tools and know-how. And many of you may have heard of nature-based solutions that have been discussed as a sort of a cost-effective way of storing carbon in existing managed or not managed landscapes cost effectively, meaning that you don't have to put an initial investment into building, facilities or such. And currently that forest or do offset approximately 12% of the carbon dioxide emissions in the US. So with that, I think, nature-based solutions have been revolving more or less around forestry in the US in the last 5 or 6 years. And one of the main pathways, so there are essentially 3 forestry pathways. The reforestation, avoided conversion, and improved forest management. And the last term, improved forest management, is kind of an umbrella term for management that occurs as a alternative for business as usual forest management. And until this term was more or less introduced through these carbon markets, protocols developed by entities supervising and running these markets, we don't really know what improved forest management means in sort of silviculture or on the ground practical forest management. And it has created a kind of a vacuum, both in resource and also a bit of a disconnect between the markets and what really happens in these existing offset projects and how we manage forests en masse outside of the markets. So what some of our research in my lab has found is that out of the forest carbon offsets in the market, 80% originate from forestry projects. So we can say that projects that can sell forest carbon offsets are the ones that kind of dominate the voluntary market. A classic example I like to give is that if you buy things from Etsy or send mail through certain entities, it says that your shipping has been offset by some sort of carbon investment. And Etsy is one of the companies who has purchased these voluntary carbon offsets, and they're all originate from forestry projects. So 58% of all credits, and this is again within the US context, and in California, we'll go over the market details in a bit, but that's a significant number because that 58% also includes companies who are obligated to participate in the California cap and trade and have to then buy these allowances. So even out of those allowances, 58% come from credits that originate from forest. So these are fairly large numbers. So we've identified that forest carbon offset credits are the sort of main credit being sold and traded in these markets. So what are these offsets? I guess that's important to define, particularly for us in forestry. So essentially how offsets are defined and within the California cap and trade and the voluntary offset carbon market, so 2 entities run by California Air Resources Board here in the state, is that offsets being quantified as a metric ton of carbon dioxide, or carbon, excuse me, are real, quantifiable, enforceable, permanent, additional, and verified reductions. So what does that odd sounding sentence actually say is that they have to be real. So that carbon has to exist somewhere. It has to be quantifiable, right? So we talk about the unit. So there has to be that certain unit of carbon, as well as enforceable, that you can monitor it. Permanent, meaning that is there to stay more or less, and additional, which, these two words can create contradiction. And I think we've struggled a bit with that in forestry. And verified reductions of greenhouse gases generated from projects in the economic sector. And reductions, essentially verified reductions, refers to the fact that this offset is somehow offsetting carbon dioxide emissions at a different sector. And the unit is, of course, a ton of carbon dioxide. My apologies for my mishap earlier. And that in the US is about 1.1 tons of carbon dioxide. The metric ton and the US ton are kind of close to each other. So another figure, and this is kind of showing how the cap and trade as well as the voluntary market in California has changed over time. In the past, there used to be a lot more greenhouse gas emissions being quantified through the allowances, meaning that this is part of the cap. So these are, again, our companies who have to, by regulation of the state, participate in these markets to pay off some of their emissions. So typical examples here would be oil and gas companies, heavy industry, thinking of like cement production, so companies that have a harder time reducing their emissions in a timely manner and thinking of from their production. So they can then buy these allowances and in turn also sell them if they don't use them that year. But we've seen a kind of a drop in allowance budgets over the time. So thinking of this as a budget that California would like to see, that the amount of allowances there would be less available and less purchased over time, and the voluntary market would then still have a small but a part in reducing the overall carbon dioxide emissions in California. So I mentioned that there are two markets. So there's a voluntary market. So I mentioned, examples like Etsy, but UPS, Delta Airlines, Avis Budget, are all companies that have purchased these forced carbon offsets from the voluntary market. New companies that have done that, or not new, but recent companies that have come forward that they purchased these include Facebook, aka Meta, Microsoft, Yelp. A lot of these tech companies are also investing in these in the forced carbon offsets in the voluntary market. Then we have the other thing that's, more of a legal requirement. So this operates in a different system. And this too is overseen by California Air Resources Board. And these are companies who are, again, required to reduce emissions by law. So they are required to buy a certain number of allowances if they are not reducing their emissions. So how does this crazy sounding market work essentially? I won't spend too much time on this figure because it looks very complicated, although we kind of look into it, it's not, but this just highlights the differences between the markets. So compliance offset market is very much a compliance market as implied. And these projects, even if they're forestry projects, they have a 100-year monitoring requirement. So thinking, as an example, you're wanting to sell off carbon offsets from a certain type of forest stand, XYZ, you have to make sure that through monitoring, that carbon stock that was there in the beginning is going to be there at the end of the 100-year monitoring period. The voluntary offset project is a tiny bit different in a way that depends which type of company you are going to be contracting with. So there are two registries essentially. Well, there are three, but two of them hold most of the offset program forest carbon credits in the US, and Climate Action Reserve that operates on the West Coast, as well as American Carbon Registry that operates more on the East Coast. Vera is a third protocol developer that also has projects coming up in different parts of the country. The difference between these, the key difference is just the monitoring period is different. So Climate Action Reserve is about 100 years versus American Carbon Registry is 40. And in the sort of carbon market lingo, this time frame is referred to as permanence. So if we look at this figure, we kind of look at it on your left, we can see that there's kind of these funny looking balls that go into the as inputs. So for an entity, be that a small family forest owner or company or an NGO, if they want to develop a forest carbon offset project, they have to start with verification. And by that, that's often referred to as forest inventory, meaning that you have to make sure that that stand is measured and establish that baseline. And that forest inventory is not a cheap task. So this, of course, involves often very significant investments of money. So the current estimate that I was able to get from Climate Action Reserve is that developing both a compliance or a voluntary offset project, the cost for doing that is in between 125,000 to 160,000. So that already is a sum big enough that it gives us indication that a lot of the smaller family forest owners in the U.S. are kind of being, if not pushed out of the market, it's harder for them to participate in that because of that restriction of the cost. Also, if we just look at the kind of the gray box in total, this process takes time. So it can be anything between a year and 5 years before those offsets are finally issued by California Air Resources Board. And this number is probably about a year old. So I would say that we're now at 240 million offsets. So approximately 240 million voluntary offsets, as well as these allowance offsets, have been issued through the California voluntary offset market and the cap and trade market. This is something that I was able to get from a colleague who was a previous employer at Climate Action Reserve, kind of highlighting too that what I mentioned briefly, how to forest project receive credits. This is a outdated timeline in a sense that there are projects currently that take less than 2 years, but there are projects who have taken more than 5 years to finally receive the credits. But this gives a general good idea of how these projects are developed, what sort of work goes into it, what the timeline is, what is required at each step before the offsets essentially trade hands. So we've kind of looked at carbon, where is it in forested systems? We've looked at potentials for trading it in the California offset market here in the US. I guess the question now is that since many of us are foresters on this webinar, or at least interested in forestry, the question is that how do we find improved forest management at the sort of stand level management scale? So I ask a lot of my second or third or fourth year students in at least one class for them to write down on paper how they would define improved forest management, and if they actually have a definition for it. And it's been kind of eye-opening because many of them are saying that they don't know what that means. So this has been kind of the overarching question for a lot of the questions in my research lab, as well as, kind of guiding teaching in a while, is that what exactly is meant by improved forest management? So it seems that we have this term coined by entities who are not necessarily related to forests per se in terms of the market context. So we've found there is a clear disconnect between how do we define improved forest management in the practical context. And there's been a lot of speakers in this webinar, not just this year, but in the past, who've pointed out to the same issue. Another problem that comes up a lot is that currently the most common type of forest management that's been considered improved forest management and the markets is extended rotation, meaning that you're not going to harvest at a given date, but instead you're going to essentially retain the trees in the environment for an X amount of time. And that in itself can cause issues, particularly in disturbance-prone landscapes. So we'll kind of go back to that in a minute. And finally, until very recently, there isn't a lot of information available publicly, or it was available publicly, but it was not kind of squeezed into a human accessible form, essentially, where these projects are located. So these have been some of the guiding principles that we've looked at in our research. So why do we want to do this? So we're interested, particularly here in California, knowing that a lot of these offset projects are located here, and the central ethos is that these offset projects are due to benefit, the people and the taxpayer of California by reducing carbon dioxide in the atmosphere. But coming from forestry, we of course know that forested areas in parts of the West, and also thinking of parts of Canada too, face these sort of existential threats in terms of fire, as well as drought dynamics. So we kind of set off to try to assess these forest carbon offset projects in the silviculture context. So we know that first, the demand for these forest offsets have exploded in the last decades. And the demand for these types of forest-based offsets, it still existed, expected to increase a lot in the next decade. So some of the work that we have already completed has highlighted that these are the sort of main areas that we have seen the largest forest carbon offset projects occur in. We have a lot of the bigger projects on the West Coast, but there's some very large examples as well as in Alaska, and a lot more also popping on in the Appalachian region, more on the eastern side of the country. So probably a bit hard to see, but again, these slides will be shared. But this is also from a publication that we put out in 22. And it highlights the different ownership as well. So thinking of who owns these offsets and what sort of management is applied. So what we did in our work was that we essentially went into all the existing public databases that list all the details of these existing forest carbon projects. And after that, we extracted the information of who owns them, where are they located, what sort of primary management type is applied, if any, and what sort of secondary management type is applied, if any. And this was kind of an ambitious attempt also too, because if anyone ever has looked at these offset documentations, there are many, and they're not very specific sometimes in terms of what sort of forest management is applied. We are not looking at silviculture prescriptions. We're just picking out keywords. But these are some of the very interesting results that we did find, however. So almost half of the offsets that have been purchased by private companies, so again, examples, Etsy, Meta, mentioned that there's no management whatsoever. The problem there became for us fairly fast is that how do we distinguish between no commercial harvest, if there's no mention of harvest after that sentence, and no management. So we decided to split them up, but this again kind of highlights the ambiguity of these terms in the offset documentation. And then there's many projects that mention uneven age forest management, but doesn't specify what type. So often there wasn't even a mention of what the forest type is that this uneven age management takes place. Some mention thinning. Many, regardless of who purchased or essentially purchased those offsets, mentioned also retention. So that too is kind of a term that we have question marks in forestry, retention. Okay, so in what context? What are we retaining? Are we retaining habitat? Are we retaining live big trees? Or are we retaining, certain environmental variables or habitat structure and so forth? And only a few actually mentioned regeneration overall. And these were all offsets that were more or less in the private issued and by private companies for them to purchase. So again, going back to the map, California, Alaska, Washington have the largest projects, and thinking of who buys these offsets are more or less private companies. We saw more or less an even split between uneven age management and no management, and a lot of them again mention retention. So thinking again of like retention, I think it's raising questions that we couldn't find much detail there in the documentation. Some offset projects mentioned that they're maintaining essentially or retaining a high basal area, or greater retention of canopy, overstory retention, retain biomass, retain recruitment trees, but no specifics were given essentially to what scale or in what quantities are those variables retained in the forest system. Another important finding is that a lot of these existing carbon offset projects in the US are located very much in high wildfire hazard potential areas. So this again kind of demonstrates the fact that if we have these existing offset projects, they have a permanence requirement of 100 years. We know how likely fire, particularly in the form of accidental wildfire, is going to return into the landscape. Many of these offset projects are prone to burn, and some have already done that in some of the bigger fires in California. Okay, so nearing the end here, I appreciate your patience. So solutions, right? We have to think about how can we, respond to some of this market demand for nature-based solutions, as well as apply our knowledge in forestry in making sure that we actually do see some added carbon benefits from these projects. Of course, one has to mention data, right? So not just thinking of, data being the foundation of sort of regulation for forest management in an international context, but also thinking that we know that a lot of these data tools, remote sensing, LiDAR, even I don't work in AI, but I know folks who do, we have this AI component in sort of improving the accuracy of inventory data, also improving and being able to detect changes in these landscapes at a faster scale, comparing different satellite imagery and so forth. So I think there's been a lot of development in thinking of these sort of geospatial monitoring frameworks. And one of the success stories in that context has been more in like global deforestation watch. And this is from a IPCC report that highlighted in 2022 that 27% of the global net forest greenhouse gas sink occurred within protected areas. So that's also something to keep in mind. So while we have an opportunity to manage on like sort of working lands and timberland, there's also an opportunity to actually protect or conserve, maybe including some management, certain areas. And globally, these protected areas have been a very sort of effective sink of carbon. So thinking of the US, right? So solutions, these are great pictures from Central Washington. This is a project by the Nature Conservancy. I'm blanking out who else was involved in this, but you'll find this online available both as a publication. The picture, one of the main authors' name is shown there in the slide. So we're looking at a multi-layered, dense, dry mixed conifer at the top left that has experienced 100 years of fire exclusion. So essentially fire has been put out from the landscape very effectively. And then if we move on to the right picture at the top, we can see that this is kind of what the stand looked like after a variable density thinning management. So for many of you on the call, thinning sounds a familiar bell. So essentially they remove trees from different size classes. That's kind of a traditional example of variable density thinning. And then if we move on to the bottom right, we can see that this is the treated area with the variable density thinning. And this also had a pile and burn and also broadcast burn. Almost forgot that. And then if we move back to the left, we can see that that's the post-wildfire photo. So meaning that there was actually a wildfire that occurred post these treatments in 2015, and we can see a lot of the trees were actually able to survive a fire. So we don't see high upgoing wildfire scars. Had it been too dense in the beginning, the outcome would have been completely different. So that brings us to an important point about assessing carbon in the landscape context, right? So we often, when we think about forest management, we do think about the individual tree, but we scale up. So we start thinking about groups of trees. We start thinking about cohorts. It goes up to a stand, and then we think about a landscape. And this is a great image from a professor or a researcher at OSU who kind of highlights well that as soon as we kind of back up and scale, we have a bigger scale. Of course, that the changes in carbon storage are going to be a lot smaller in terms of that whole landscape and the response to management than if we just look at an individual stand where we're going to hypothetically remove trees from. I want to show this too, just as a reference. The Parks Service has these cool projects, particularly in the Midwest area, where you can kind of see them online. You can see their pre and post treatments, particularly using, essentially thinning and also fire and reducing the biomass in these, or woody biomass in these stands. So why do I talk about that is that, we have to be able to have resilient forests in the future so that they can provide forest carbon offsets, as many other services as they do, but offsets being one of them. And some of the tools that many of you here in the webinar already work with are, we think about retaining forest. We actively regenerate after fire. We try to protect and support soil productivity, reduce wildfire risk, but by that also reintroduce fire into the landscape that we're really trying to do here in California. And then we have to think about, this is a very important point that I always want to highlight, is that, carbon is just one of the many outcomes that we see from our wonderful forest system. So it's just one ecosystem service. So we shouldn't manage all the stands on productive timberland in the US just for carbon. And then thinking of substituting forest biomass with fossil fuels. That's probably not going to happen for a while in California, but I'm sure there are efforts on the way, essentially on the East Coast for this too. Couple of things that are important to mention before I let you guys go is that voluntary carbon markets joint policy statement and principles that came out. I appreciate Tony for tipping me on that. And another good resource for thinking about more of a global scale, thinking of IPCC's reports highlights the importance of forest restoration, as well as thinking of forests as a carbon sink and as a nature-based solution. What I do want to highlight from the voluntary carbon market joint policy statement from the White House is that there's many researchers, including myself, whose work is included in this, that they're all discrediting methodologies that I introduced, but essentially they're not they're not incentivizing management, essentially, because you're assuming there's an assumption that if you don't manage, the carbon is going to be retained in the landscape. So that has created a lot of issues, particularly thinking in the California market context, not to mention the tropical system. And that being said, we've been offered a lot of solutions, and we've done that too in the context in our lab, is to kind of think of underscoring the need for having a robust framework of highlighting different management tactics, as well as testing them on the ground, and just going beyond the fact that we use these kind of vague terms of retention and no management or no commercial harvest. One thing I do want to mention here is that we can't just think of planting trees as the solution for saving a lot of not saving our planet, but thinking that this is the only way to sequester carbon is to endlessly plant trees. I have to say that, as in my profession, I'm very much against that, because what we already see in the West here is that we have hard time introducing trees to badly burned landscapes. And these are landscapes where trees used to be, not to mention that there's this effort, globally, to plant trees everywhere. So we can't just think that nature-based solution one is just tallying planted trees. And another important point is that 92% of the world's forests already have a human hand in them. So we're thinking of secondary forests. So I think we do have an obligation to maintain those systems, and that often includes management. So what to remember from this talk? I mean, it was kind of a whirlwind, but highlighting in terms of like the specific focus of forest carbon offsets in the US, we actually do need to vet the existing carbon projects in the forest realm for their carbon benefit, right? Is there any sort of management occurring that is actually sequestering more carbon in those projects? We need to assess them for the realistic disturbance risk. That's just has to happen soon enough, because we know that fire is a big component of and a big risk on the West Coast, for example. Maybe we need more oversight. And this point gets a lot of pushback depending where I highlight it in, but sometimes we might need oversight in terms of kind of validating the carbon benefits. And we need to finally, most important thing, to clarify the terms of forest management applied in this existing forest carbon offset projects. And I almost went over time because college professors like to talk, but so I just want to thank all entities who have funded a lot of this work, and obviously the great students who keep doing this work in my lab. And with that, I will open the floor for questions.